Welcome to the frequently made mistakes that I found during my review of assignment 3B. As you've no doubt noticed, this assignment is a bit more complicated than some of the other ones. So make sure you watch this video carefully, and also make sure you come to office hours and/or post on Piazza if you have any questions. So to start out my review, as always, make sure you document your code, make sure to address all my comments from earlier assignments, and of course, make sure all the unit and integration tests are passing. Please also read the Tom Cargill article about the specific notification pattern, especially listing 3, at the link here, and also watch my video that walks through this pattern on YouTube at this link, and follow those instructions because they'll give you lots of great hints. Let's start with a quick summary of a problem left over from the previous assignment. This is the await completion of futures method, and in this particular implementation, the filter expression is incorrect, it's backwards. And also try to get in the habit of using the rethrow supplier adapter function instead of having to wrap your code with all the weird try-catch blocks, which are ugly and don't work very well with streams. Now let's turn our attention to some of the issues that are related to the fair semaphore implementation. If you're doing the grad student version, make sure to use the supertype here rather than the subtype. Just get in the habit of doing that. It's a good habit to get into. And down here, for either the grad or the undergrad version, something important is missing. So take a look at the comments, which basically say that you have to have a type qualifier that will ensure that reads and writes to this field aren't stuck in processor caches. In addition, don't define this field as static because all kinds of crazily bad things will happen. Let's now start turning our attention to some of the implementations of the methods in the fair semaphore class. So acquire uninterruptibly should have no locking whatsoever. This code locked the lock for some strange reason and never unlocked it. But irrespective of that, you shouldn't be doing any locks or unlocks in acquire uninterruptibly. That method should only be delegating to the acquire method within a loop and then doing the appropriate checks to see whether an exception or an interrupted exception has occurred. Now let's start talking about the try to get permit method. A number of interesting issues here, both with the grad and the undergrad version. We'll try to start with the grad versions first because more people did those. So you don't need to do any synchronization on MQ. That's overkill and unnecessary. Looking at this implementation for some odd reason called try to get permit unlocked twice. There's no need to do that. It's unnecessary. It's inefficient. Just if you need to record the value, if you don't want to use control constructs to do the right thing, then store it in a Boolean field or Boolean variable rather, and then check that variable in the finally part. But there's other ways to do this as well. Let's take a look at another issue with try to get permit. This one is for the grad version, but basically similar kinds of issues here. Don't put the logic for checking whether you can get a permit or not in try to get permit. Instead, put it in try to get permit unlocked. That's the whole point of that method, to factor that code out. And another thing to note for the graduate student version, though not for the undergrad version, you don't want to be calling unlock on the monitor lock, on mlock. You should only call unlock if the call to try to get permit unlocked returns true. So in that particular case, you're done, and so you want to bail out and return on the happy path, the fast path. Let's now turn our attention to try to get permit unlocked, which should look pretty much the same for both the grad and the undergrad versions. First, make sure you properly do the appropriate conditional check here. This code is incomplete. Take a look at the comment above to see what you're supposed to be doing. And also, this code should not be doing any calls to unlock at all. That's the whole point of the try to get permit unlocked method, is to factor out code so that there's no locking required at all. And that actually uses the thread safe interface pattern. Let's now come down here and take a look at wait for permit. I'd have to say that most people who had problems with wait for permit. So we'll start off here by taking a look at the undergrad version. So first of all, make sure you don't do anything without getting synchronization in place. You're setting a flag here and you're calling wait, but nothing's been synchronized at this point. So of course you'll get some kind of illegal argument exception here, or wait will return a weird result. Anyway, it'll be wrong. And also, this type of code needs to go into a loop. Remember that we always call wait on monitor objects, or we always call await on condition objects in loops for reasons we've talked about at length in the class. This code here has the synchronization backwards. It's also in the wrong place, but leaving that aside, first you have to synchronize on the waiter, and then you'll synchronize on this. So this code has got many problems. Let's take a look at another set of problems with wait for permit. So in this case, this is somewhat nested inside of some other code. You need to be calling try to get permit unlocked here, since the whole point of that is to factor out common code. Moreover, the code that's being done here is incomplete and incorrect. So make sure you try to get permit unlocked working and then call that here. You also only want to add the waiter to the wait queue if try to get permit unlocked returns false. In other words, if we aren't able to get the permit. If we're able to get the permit, then we want to go ahead and return from this method immediately and not do anything else. We don't want to be waiting in that case. Down here, you can see there's another bunch of problems. So again, always make sure that you call the wait method or the await method, depending on which implementation you're doing, in a loop, and also be checking to see whether or not the condition waiter.mRelease is true or not. So those are important things. Just got to get in the habit of doing that. And there's no reason to call try to get permit unlocked here. That method doesn't belong here. It belongs much further above. Now let's take a look at what happens when things go wrong and an exception is thrown. So lots of people struggled with this. Don't use exception handling here. Just check the return value from remove. There should be no need to do this. And I'm not sure even what this code is supposed to do because it's calling remove, which I think is trying to remove the first item. So this is just the wrong thing to have altogether. You want to return the item that is the waiter. So you have to do that. Again, if you watch the video walkthrough I did, it'll explain all this. No need to reset the interrupt flag since we're throwing the interrupted exception. So you don't need to reset that flag at this point. Let's take a look at some other problems people had in wait for permit for the undergrad version. Once again, you only add waiter to the wait queue if try to get permit unlocked returns false. Don't just unilaterally call it. And this code has got all kinds of problems. First and foremost, it's calling wait with the intrinsic lock held. In other words, synchronized this, which is bad. So make sure you reread the Tom Cargill article for more information about how to structure this code. And also the condition expression here is incorrect. I'm not quite sure why it's trying to bitwise or m permits less than or equal to 0, but that makes no sense whatsoever. Then the rest of this code is just incomplete, so please watch my YouTube walkthrough, which gives lots of great details and hints about how to do this. Let's take a look at another problem with the undergrad version of wait for permit. This implementation is also very incomplete and incorrect, so watch the video and follow those steps. I don't even want to comment on this. It's just absolutely chock full of bugs and it doesn't make any sense at all. Here's another issue. This particular code is calling try to get permit unlocked without holding the intrinsic lock. So you have to make sure you only call methods that can manipulate shared mutable state with the intrinsic lock held. And then down here, we have some other problems. We don't need to synchronize on mwait queue here, but you do need to synchronize on the intrinsic lock because once again, we're about to access shared mutable state, namely the state that's in the wait queue. There's no need to call contains, just call remove, and then make sure you check to see what the return value from remove is. Much more efficient and more effective way to do things. Now we're starting to transition into some of the grad student mistakes I saw. Make sure that you never call the lock method inside the try block. That should be moved outside the try block for reasons we've talked about many times. And also always make sure, likewise, to call unlock in a finally block. Down here, make sure to call await in a loop, not with an if statement. We've, again, talked about this repeatedly in the class and the videos and all other discussions we've had. You don't need to make the remove call here. That's unnecessary. You don't need to call release unless remove fails. That's also unnecessary. But it is necessary to get in the habit of calling unlock in a finally block. So that's incorrect. Here's where some exception code is done incorrectly. So again, this code has race conditions since there's an access to shared mutable state, namely the wait queue, without holding the monitor lock, which in this case is guarded by the mlock ReentrantLock. For some reason, mlock is being called here, which is too late. This code below is way too complicated and incorrect. So please go back and watch the video again and follow those instructions. I'm not even going to try to talk through this. It's just full of bugs, so make sure you fix all that. And then make sure you call unlock in the finally block. And I'm not quite sure what this is doing here, but it's duplicative of what's above, and it's also just wrong. There's no need to do any of this stuff. Let's take a look at another problem with wait for permit from the grad student version. So the first thing you have to do is you have to make sure that the code here, this call to add, is inside a nested try finally block so that you can unlock the lock as soon as add succeeds. Once again, make sure that you're calling await in a loop to guard against spurious wake-ups and other weird problems that happen to occur, race conditions, or I guess better word is the non-determinism aspects of concurrency. This code doesn't properly handle the case where an interrupt exception is thrown. And this call here doesn't belong in finally. It belongs in the catch clause for the interrupted exception. So once again, go back and rewatch my video walkthrough that talks about how to implement the specific notification pattern. Now let's turn our attention to release. People had fewer problems with release than with wait for permit, but there are a bunch of problems. We'll start again with the undergrad version. So one thing to remember is refactor your code so you don't hold the intrinsic lock for such a large duration. You only need to hold the intrinsic lock for the portion in release where you need it to protect internal state. And you can do a really clever technique here by using poll, which doesn't block, instead of isEmpty and remove or remove first or whatever. So if you do that right, then you only have to synchronize on a very short piece of code. And then you can take the results that come back, release the lock, and then use those results to guide what comes next with the lock that's been released. In this particular case, also, you don't want to be acquiring the intrinsic lock twice. You need to refactor your code so that you only acquire the intrinsic lock a single time. And again, that will be well served by using poll correctly. No need to keep reacquiring the intrinsic lock. It's inefficient. Down here, this implementation is just incomplete and wrong. I'm not even going to try to explain it because it's just lacking in almost everything. So please go back and rewatch the video and see what you're supposed to do. Down here, a number of people got confused for some reason, and they didn't have synchronization around code that accesses shared mutable state in the fair semaphore implementation. So that'll cause race conditions because you're not synchronizing on the intrinsic lock, but you're accessing state that will be corrupted when called from multiple threads. And then for some reason, we're doing a poll up here to get the first item. And then down here, we remove it again. So we don't need to poll it and remove it. What you want to do is you want to do poll, and then you want to make sure that that's properly synchronized. And once again, there's also a race condition here because we're incrementing shared mutable state, namely mAvailable permits, without holding the intrinsic lock. Moreover, you only want to increment mAvailable permits if the wait queue is empty. If the wait queue is not empty, then you're not going to increment available permits. Instead, you're going to notify the waiter that's been waiting the longest in a FIFO order, which is the whole point of the specific notification pattern. This code also has race conditions since shared mutable states being accessed and updated without holding the intrinsic lock. And then there's just a lot of mistaken code down here. So go back and watch the video. There's no need to synchronize on this in this particular case. That's you're going to have to not do that. There's no need to do that. In fact, it will probably cause problems because you're not accessing the shared mutable state for the fair semaphore monitor object. Instead, all you're doing is you're notifying and releasing the waiter that's at the front of the queue. Let's take a look at some more examples of problems with release. This is again still part of the undergrad version. Once again, please refactor the code so that the intrinsic lock is not held for the whole duration of the method. And again, you don't want to be using remove first. You want to be using poll. Only increment the permit if there's no available waiter. So if there was a waiter, we're going to notify it and not increment the permit because we're basically going to pass off control to the waiter that we're waking up. So you only increment permits when there's nobody waiting. And also, don't be calling notify on the monitor object. Instead, call notify on the first waiter wait object, basically the thing that you got out of the queue. Some more problems down here. Once again, we've got issues where we've synchronized, and then once we're out of the synchronized block, then we're accessing shared mutable state. And the way to solve this is basically to use that call to poll. So make sure you do that correctly. And yet another problem, now we're into the grad student code and problems that I saw there. So as with the undergrad version, don't hold the monitor lock for the whole duration of the method, just hold it for the part which accesses shared mutable state. And again, get rid of these calls to isEmpty and replace them with a single call to poll. This particular part of the code should not be being called with mlock held, so you need to refactor that so that mlock has been released by the time you go and do the signal call. And then we're almost at the very end of the fair semaphore issues. So if you have the appropriate type qualifier on mpermits, or whatever you called it, then there's no need to synchronize. In fact, that's the whole purpose of having the appropriate type qualifier on mpermits in the first place, is to avoid the need to have to synchronize that. So using the right type qualifier will do an implicit synchronization that's much cheaper than doing synchronized. Let's now turn our attention to issues with the Palantiri manager portion of the code. This is the one that uses the concurrent hash map and, of course, our fair semaphore. So first thing here, there's no need to allocate a concurrent hash map and then use a collector, because that's the whole purpose of the collector. And this collector is too complicated. You don't need to use the 4-parameter version. Just use the simpler 2-parameter version of concurrent map, which just creates a hash map, concurrent hash map, of course. Also, don't use the 2map method with 4 parameters. Use 2concurrent map with the 2-parameter version. Let's now take a look at some problems I saw with acquire. So this code has all kinds of race conditions. It completely misses the point of using the concurrent hash map, which is to use the 3-parameter version of replace. So this code is full of race conditions. There's a lot of problems, by the way, with people who didn't understand the purpose of concurrent hash map. So you need to go back and rewatch the video on concurrent hash map where I talk about the 3-parameter version of replace. This code also has race conditions. There's no locking that's protecting this, so it's full of race conditions. You don't want to be doing this code. You want to be using replace instead. Down here, once again, don't use entry set, but use key set with a Palantir. And don't use the 2-parameter version of replace, but use the 3-parameter version of replace. And that's because the 3-parameter version of replace supports the so-called compare and swap semantics, which are really cool. And you don't need to be throwing a cancellation exception here. You don't need this cast if you use key set instead of entry set. And whenever you throw an exception like illegal argument exception or cancellation exception, please provide a string that explains why you threw the exception. It helps the program or the reader figure out what's gone wrong. Now, when you do a loop, and there should just be a loop here, make sure you wrap an extra forever loop around the for each loop so that you will make sure that you keep iterating until replace returns true. The 3-parameter version of replace returns true. Also, don't use key set, don't use entry set, use key set, as we've talked about below. And this code is inefficient. There's no need to be calling get. Just call replace. That's all you need to do. And read the documentation of replace and go back and watch my video about the 3-parameter version of replace to see more about the motivation for that. A number of people tried to be too cute. They tried to use Java streams. That shouldn't be used at all here, really. So I guess this explanation should be, and don't even use streams at all. Instead, you want to use the loop that we've been talking about, or the loops we've been talking about. A number of people tried to write code like this, where they're trying to use Java streams. This is inefficient. It's complicated. There's situations where it has race conditions. It certainly doesn't leverage the power of the 3-parameter version of replace for concurrent hash map. So don't use Java streams. Just use the for each loop nested inside of a forever loop that will iterate through the key set and call the 3-parameter version of replace on each key until you succeed. There should just be a very few number of lines of code. It's really clever and really clean. Let's now turn our attention to release. First thing here, don't use the 3-parameter version of replace. Instead, use the 2-parameter version of replace. And down here, make sure that you always indicate why you're throwing an exception by providing an informational string. And also make sure that you use replace instead of put. And as we'll talk about in a second, make sure you check the return value from replace correctly. So this is something that's left over from assignment 2B. A lot of people obviously didn't address my comments there. So make sure that you will check the return value from replace correctly. So if you just check for Boolean, that's inadequate because replace can also return a null value, which is not the same as true. So you need to make sure that you check this properly. There's a bunch of different ways to do it. My recommendation would be to compare to see if the result is going to be equal to boolean.false. If it's equal to boolean.false, it's correct. If it's not equal to boolean.false, it's incorrect. And that'll clean things up here. And then also make sure you don't just unilaterally call release on the semaphore, but only do it if replace returns the appropriate value, which it doesn't do in this case because we're not checking to see if it returns null. So lots of stuff to think about. This is one of the more complicated assignments, arguably the most complicated assignment, although 4B has also got some interesting things in it as well, where we do stamped lock. But what you need to do is, again, go back and read the Tom Cargill article, look at listing 3, walk through or rewatch my video description of how all this stuff works, where I kind of visualize how it works and describe it verbally, but also make sure that everything is passing the unit tests. And certainly if things are failing, don't just sit there confused, but come to office hours, reach out, talk to the TAs, talk to me, post questions on Piazza, and we'll see if we can get everything working.